When you hear the word battery, you probably think about, your phone, maybe your laptop. But what if I told you that this little everyday device is actually the key to a world completely free of fossil fuels? I know, it's a huge claim, but it's a future that's getting closer every single day. And hey, don't just take my word for it. Back in 2019, the Nobel Prize Committee pretty much said the exact same thing. This was when they awarded the prize for the invention of the lithium-ion battery. This isn't just about making our gadgets more convenient. No, this is about a fundamental shift in how we power our lives, making things like solar and wind power usable 24/7, and of course, putting electric cars in every driveway. Okay, but let's be real. It's a pretty big leap to go from a tiny AA battery to powering the entire planet, right? So how on earth did this humble little power pack become one of the most important technologies for our future? Well, the story actually starts way, way earlier than you'd think. To really get where we're going, we've got to look back. See, this whole dream of an electric world, it's not some new thing. It's an idea that's been kicking around for about 140 years, just waiting for one single piece of the puzzle to finally fall into place. So, the whole story kicks off way back in 1859 with the very first rechargeable battery, the lead-acid cell. And it did not take long for people to get creative. By 1881, the world's first EV, which was actually a tricycle, was cruising the streets at a blistering 12 kilometers an hour. Even the great Thomas Edison got in on the action, trying to build a better battery just for cars. And believe it or not, electric cars were actually pretty common in the early 1900s. They were quiet, they were clean, they were way easier to start than the hand-cranked gasoline cars of the day. But the dream just died. And the problem wasn't the car, it was the battery. They were monstrous, heavy things, often filled with leaky, dangerous acid. Not exactly ideal. You basically had two options, and neither was perfect. The lead-acid battery was the reliable old workhorse. Cheap and tough, but just way too heavy and didn't hold much of a charge. Edison's battery was more powerful, sure, but it was crazy expensive and, well, it pretty much gave up if it got cold. For the electric dream to have a real shot, the world needed a completely new kind of battery. And that, right there, brings us to the real game changer, the massive breakthrough that makes our modern electric world even possible. This is the lithium revolution. The mission was simple, but incredibly ambitious. We had to untether our lives. For phones to actually fit in our pockets, and for electric cars to be a real alternative. We needed a battery that was light, incredibly powerful, and could be recharged not just dozens, but hundreds or even thousands of times. We didn't just need a small step up, we needed a giant leap. And that leap came in three crucial steps, thanks to three absolutely brilliant scientists. First, in the 70s, Stanley Whittingham proved the basic concept could actually work. Then, a few years later, John Goodenough literally doubled its power with a new material. But the final piece of the puzzle came from Akira Yoshino in 1985, who figured out how to make it safe and stable enough to actually sell to people. Their combined work changed everything. The genius of the lithium-ion battery is how simple and elegant it is. Instead of some messy chemical reaction that destroys the battery over time, you just have these tiny lithium ions that shuttle back and forth. It's kind of like they're guests checking in and out of a hotel. Because the hotel itself doesn't get destroyed, the battery can do this thousands of times. And that durability, that was the game changer. But look, a brilliant invention is one thing. The real reason we're having this conversation today is the absolutely staggering drop in cost. Just think about it. In 2009, 1 kilowatt hour of battery storage cost $1,000. $1,000! Today, it's around $200. That insane price drop is the reason electric cars are becoming affordable, and it's why huge solar and wind farms finally make economic sense. But of course, this story isn't over. As amazing as the lithium-ion battery is, it's not perfect. It's got its own set of pretty big challenges, bottlenecks that we absolutely have to solve to keep moving forward. And here's something that might shock you. For all the hype, lithium-ion isn't even the most common rechargeable battery out there today. Nope. That title still belongs to the old-school 150-year-old lead-acid battery. It holds over 60% of the market. It just goes to show you the massive, massive scale of the transition that's still ahead of us. So to really take this tech to the next level, we've got a clear to-do list. We have to deal with the supply chain for materials like cobalt. We desperately need to figure out recycling. Right now, only a measly 5% of EV batteries get recycled. We have to keep making them safer by stopping these tiny, spiky crystals called dendrites from growing and causing fires. And of course, the big one, energy density. I mean, gasoline still packs 50 times more energy for its weight. Closing that gap is the ultimate goal.
But this is where things get really, really exciting, because researchers all over the world are tackling these problems head on. It's a global race to build the next true super battery.
So first up, you have solid-state batteries. The idea here is pretty simple, but it's totally revolutionary. You get rid of that flammable liquid inside a normal battery and replace it with a thin, solid material. Right away, that makes them way safer. But it could also let us literally double the amount of energy you can pack into the same space. We're talking about a phone that lasts for days or an EV that gets twice the range. Then you've got lithium-sulfur. This idea tackles the cost and supply chain problems by swapping out expensive metals for sulfur, which is super cheap and one of the most abundant elements on Earth. And the potential payoff here is just wow. Theoretically, these batteries could store 5 times more energy than what we have in today's EVs. And then there's the holy grail, the metal-air battery. This thing essentially breathes. It uses oxygen straight from the air as a key part of its chemistry. If we can crack this, a lithium-air battery could finally match the energy density of gasoline. That would mean an electric car with a 1,000-kilometer range that weighs the same as a regular car. That's the dream. And the innovation isn't just about what's inside. It's also about the shape. Scientists are now building batteries in 3 dimensions, creating these incredible microscopic structures that can cram way more power into a much smaller space. So yeah, the flat, boring battery pack we know today might be a thing of the past pretty soon. So from a leaky 19th century gadget to a global race for a super battery, what an incredible journey. The science is just moving at a breathtaking speed, promising a future powered by clean, endless energy. Honestly, the technology isn't really the bottleneck anymore. So the real question we have to ask ourselves is, are we ready to build the world that this technology makes possible?